Jonathan here with the Limestone Library, and thank you all for joining me for another, I'd say, exciting episode of Science with Brian. We got excellent reception on the last one. I'm really looking forward to this. He has a bunch of fun things that he's going to do with dry ice to show us. So, Brian, what do you got for us today?
Okay, well, several things. First of all, dry ice is just basically carbon dioxide, except it's carbon dioxide in the solid state, which a lot of people don't get to see very often. So, here's carbon dioxide as a gas. That's normally what we breathe out, or what you've got in your beverages at home. If you open up your beverages, and you see some bubbles coming up out of the beverage there, tiny bubbles, that's carbon dioxide in the gaseous phase. Carbon dioxide in the liquid phase is also kind of hard to see a lot of times. We don't normally think about it. Carbon dioxide in the solid phase is what dry ice is, and that's mostly what we're going to be dealing with today. But we'll get into this point right down here on the graph, which this is a temperature pressure graph. And this right here is a point where we can see all three phases together: solid, liquid, and gaseous carbon dioxide. And part of what makes carbon dioxide a little bit difficult to work with is it's a lot like air. It's a gas that's colorless. You normally don't smell it. It does have a little bit of a taste. If you get some in your mouth, it will taste possibly a little bit acidic. So it is kind of acidic in some sodas and things. It kind of turns into carbonic acid in your mouth, so it'll taste a little funny that way. But first of all, a few precautions. Carbon dioxide's normal melting point, we should say, is down around at 1 atmosphere of pressure, which is our normal air pressure. It melts or freezes down around negative 109 on the Celsius scale. Or no, excuse me, negative 109 on the Fahrenheit scale, about negative 79 on the Celsius scale. So that's pretty cold. That's well below the freezing point of water, and we don't want to be handling that with our hands or any other parts of your anatomy. So don't let that come in contact with your body. So we'll be using gloves to handle the dry ice.
So if we want to see this dry ice in all three states of matter, we have to get the temperature dead on and the pressure dead on. Am I mostly correct?
Pretty close, yeah.
Okay, so that's going to be...
To a certain point.
Okay,
right.
It sounds like it's going to be pretty tough.
Right. It can be. So where do you get solid carbon dioxide? Where do you get dry ice? Your local Myers store has it.
Really?
Yes. But you have to be 18 years old or older in order to purchase it, because it is kind of a bit of a hazard. So this is a chunk of dry ice. It looks very similar to regular ice, but it's a lot colder, and I'm just going to break off a few pieces and toss them into our bowl here. Well, actually, I can just toss them straight into some of the containers we're going to put them in. First of all, dry ice in water. You'll see the bubbling there. And why is it bubbling? That's okay, that's my fault.
Okay. I was just moving that for you.
Why is that bubbling and producing this cool vapor? It's because, like we said, it's normally a solid down around negative 79 Celsius. Well, this water is well above that, so this water is causing it to change rapidly into a gas, which is a process known as, you can even, if you look carefully at it, even on the tabletop, I don't know if you can get a close-up of that, might be better against a dark surface. You can see vapor trails kind of coming off of that dry ice as the carbon dioxide changes into a gas directly. So that's kind of funky. We've got carbon dioxide going from a solid directly to a gas at normal atmospheric pressure. And that happens pretty easy. We don't see it go into the liquid phase unless we get the pressure up a little bit here. And we'll be doing that in another demonstration. Okay? So one of the things here, this carbon dioxide is changing from a solid into a gas. It's trying to take up a lot more space, so it's causing these bubbles, forcing the cooler vapor up and out of here. And one of the things that we can do to demonstrate that pressure is we have a wash bottle here. And this is just something that we use for chemistry class and other things for washing things off. But in order to make the water come up out of this wash bottle, there's a tube sticking down in there. We normally squeeze the bottle to get the water to come out of it. But if we put carbon dioxide, the dry ice, into the wash bottle, just a chunk of it here. I get a little smaller chunk that'll fit. Into the bottle. There's one to go down in there. There it goes. Good. All right, now you can see it's creating the bubbles there, and the fumes are coming out. Now you might be tempted to screw the lid on.
Yep.
I'm not going to screw the lid on. You're going to hold that bucket there for me.
All right.
And I'm going to point the lid that direction, and I'm going to screw the bottom on.
Okay.
Take it up to the lid, and as I do so, without squeezing it, I'm not squeezing it at all. It's just the carbon dioxide changing to a gas there that's generating the pressure to force the water out of there. Oh, my squirt. No horseplay in the lab. So in a short period of time here, this carbon dioxide will create enough pressure by changing into a gas that will empty the water out of that bottle, and we'll have carbon dioxide gas coming up through that tube and out of the bottle. So it's just kind of a cool demonstration of how carbon dioxide can create pressure and how it can change. As it's changing from a solid to a gas, it increases its volume hundreds of times. So that small chunk, as it's changing to a gas, the molecules are getting further apart, it's expanding, taking up more space, creating pressure. And we got maybe about a third to a quarter of it left there.
So now, I know we had sort of a similar looking reaction with one of the demonstrations that we did in the past. It's escaping me at the moment, but it was with the elephant toothpaste where it had the exothermic reaction and it gave off the smoke that was, the vapor, the vapor that was really hot. This is safe to touch though, unlike that, right?
Right. Now that gas that it was generating was oxygen and quite a bit of steam there too.
Right. Okay.
Coming out too. But oxygen a little bit different properties.
Right.
Than the carbon dioxide here. And we're getting down there.
You can just set it inside the bag can if you want.
But we're just about out of water here.
Okay. Oh yeah.
And it should start sputtering about any moment here.
Wow.
There we go. So it's pretty well out of water.
Cool.
Almost out of water. It's still going a little bit. So to demonstrate without the wash bottle here, there it goes. Now we're getting some vapor out of it. Without the wash bottle,
Oh yeah, look at that.
I've got a couple different things that can expand. You can actually see a stream of vapor coming out of there. We'll take a piece of dry ice and put it into a latex glove here. Now I did just pick that up with my bare hand.
I was just going to ask about that.
And as long as you don't leave it in contact with your skin very long, it should be safe. Okay, I hope this is going to close that up tight enough. And keep it closed. We'll see here. I'm just keeping it moving around a little bit.
Okay.
But as that sublimes, as it changes into a gas, it should fill up the balloon there, or the latex glove.
If we have it airtight out here.
Right.
Okay.
And I think it does seem like it's expanding a bit. It's going to be a little slow
Right.
at first.
Leave that there, see what it does.
Right. And I'm going to break off a bit more of this one to use. I'm going to put a good sized chunk of this into a garbage bag and see if the garbage bag will do the same thing. See if it'll kind of blow up on its own as the carbon dioxide sublimes. So we'll see how good our ties are and stuff there. I haven't done it before with the garbage bag, but I thought as long as I had one, it might be interesting to see how big it gets.
Yeah, I think our glove's blowing up just a little bit.
It's getting there. There's still a lot of big chunk of ice in there.
Right.
Or the carbon dioxide.
Yeah.
So it is starting to puff up. Okay, another quick demonstration.
I love how they're still going.
That's yeah, these keep going for quite a while usually, as long as you got a piece or two in there.
Right.
The water bottle
Oh, look at that.
still going a little bit there. You can kind of see the vapor coming up from that one with a little bit of water in it as well. If we put this into some soapy water, we can draw or in a watered bowl, we can draw a soapy cloth across it. You can see some carbon dioxide bubbling in that soapy water already. I don't know if I can draw this across. Nope, I don't think that's going to work. Try it over here. I think I'm going to get too many bubbles. Oh, what I'm trying to do.
Yeah, look at that. That's pretty cool.
So it would be a carbon dioxide bubble. Most of these are going to be too big, I think,
Yeah.
for what I want. Takes a little practice to draw that across and get a good soap film across the entire top of the bowl. Oh, that one popped. Get some of that soap off of there. Almost.
That was pretty good, yeah. Oh yeah, you got it.
I got that over here.
I'm gonna leave it there, see if I can bring this closer. Because I don't think they're going to be able to see it on here, but if we bring it really close, you can see on the left side there's a huge bubble.
A bunch of small ones, this is a large one here.
Yeah.
But ideally, I should be able to get one much larger one coming out of the top there. I've got a little bit too much in there maybe. A lot of pressure going on there.
Oh,
there we go.
All right, there it is. First try.
Well, and you should be able to see it kind of doming up there on top. That's a little bit better view of it as it makes that bubble.
Yeah. A bit.
It works nicer if you can get it across the first time without all the small bubbles in the way. But hopefully you get the idea there. Okay, and our latex glove is getting a bit of tension in it here.
Yeah. I've been monitoring that.
So we'll see how big that gets. And we've got some carbon dioxide in our garbage bag there. Hopefully that'll get a lot larger too. So So we'll take a quick break here and set up for a lab where we'll talk about this triple point and see if we can actually get on camera all three phases of carbon dioxide in a piece of tubing for you. Back talking about carbon dioxide, and we've got a couple other things to show you before we get to the tube with the three phases. If you haven't heard George Washington squeal before, he can do that because the coin on the ice, if I get enough pressure there, the vaporization of the ice, the sublimation of the ice, as that gas is coming up, it vibrates the coin. So it works with pretty much any coin or flat metal piece. Pennies don't seem to work as well. Abe doesn't want to scream very much. That's Dwight Eisenhower. That's Thomas Jefferson. And I have a big kind of commemorative Abraham Lincoln coin from my aunt. That makes quite a bit more noise with a larger coin. So that's kind of a cool thing. The other thing about sublimation is we've got a few small pieces here on the tabletop. And you notice that as it vaporizes, it kind of creates its own friction-free surface there that it can skate around on. So a little bit of, instead of hydroplaning, a little bit like an air hockey table almost. Except it's carbon dioxide hockey. So what we've got is a large piece of rubber tubing here. I've clamped it off on one end, and I'm going to stick some dry ice chunks into that tubing if I can find ones that will go in easily. And what we're going to do is kind of create a closed environment for that dry ice, and hopefully enough pressure will build up and we can get the temperature right so that we can see all three phases of it, solid, liquid, and gas. But we're going to have to clamp off this other end in order to do that. If my clamp will get that tight. Okay, that's about as tight as she goes. This may take a little while to get this rubber tubing cool enough, or the dry ice warm enough, and the pressure built up enough in there. Usually a little bit of heat helps. This is some fairly thick tubing to withstand that pressure. The triple point here is at about 5 atmospheres of pressure, so we need about 5 times what our normal air pressure is in order to get to that. And inside it still needs to be at about a negative 60 degrees. That's our garbage bag that's getting filled up with the carbon dioxide, and the rubber glove.
Fill up quick.
Yeah, eventually it kind of gets to a point almost of equilibrium there where it doesn't want to vaporize too much anymore. It's staying as a solid a little bit better. So that also brings up the point of if you want to store dry ice, you want it kind of in as much of a sealed container as possible so not a lot of it's leaking out. And that pressure will help keep it in that solid phase. Okay, we finally got it sealed off. I don't know if you can see inside there, but we've got some solid carbon dioxide, and there's water there, or there's actually liquid carbon dioxide, and then we've got some vapor inside the tube there as well. It's just floating around a little bit. You should be able to see the liquid moving in there.
And you can probably hear the gas.
A little bit. We got a little bit escaping there. That was our problem, is we didn't have a good seal before to get it up to about 5 atmospheres of pressure. And if we release the pressure here, it should go back to a solid inside that tube. So it's a little bit like snow. in there is that all that liquid carbon dioxide changed back to a solid as we brought the temperature, or as we brought the pressure back down to normal here. It should go back to the solid phase as that pressure drops. So as long as we were continuing to increase the pressure there, we'd still have some liquid carbon dioxide, but once we allowed the pressure to come back down, now it's down here. Ice is kind of different. Water is different. The solid liquid phase for water, the line kind of comes back this way a little bit. So for regular water, as a solid, you can change it to a liquid by increasing the pressure. Or excuse me. Yeah, you can change it to a liquid by increasing the pressure. This one is a little trickier. It slants a little bit the other way. But at least we got to see all three phases. And I think our last one is burning magnesium and carbon dioxide. Normally carbon dioxide can be used to extinguish fire and flames. It's just it doesn't work real well for some very active metals like magnesium. So we'll see if we can set that up and show that to you. Cool. Okay, hopefully the last thing we can show you is that carbon dioxide doesn't put out some fires here. So we've got magnesium sitting in a chunk there. I'll light the magnesium, and when it gets going, I'm going to put the other magnesium block on top. And if it works right, it should just keep burning. Ooh. That's what we wanted.
There we go.
So the magnesium just continued to burn even though it was surrounded by carbon dioxide and carbon dioxide gas there. So my magnesium's all ash there now. So to finish up here, we got a better seal with this clamp on the glove, and you can see the glove is starting to expand more. That pressure builds up and it starts to leak out a bit. The garbage bag, better seal there. There's definitely some good tension in the garbage bag, and there is a nice, still a heavy piece of dry ice in the bottom of that, so it could keep going. And we'll just leave that here and see when it explodes on Austin later on. Same thing with the glove.
Well, cool. Thank you so much for doing all this. I'm like really impressed at all the different things that you can do with carbon dioxide. I kind of vaguely knew what dry ice was, didn't know you could get it at Meyer, and and do all these things with it. The magnesium was really neat. Don't look directly at it. Right. I found that out pretty quick. But I really hope you guys enjoyed this, and be sure to thank Brian whenever you see him. We really enjoy having him for these science demonstrations. See you later, guys.